Right, hello and welcome to the answers for homework number 2. All right, let's get this started. Homework 2. So let's just see here. What is the first homework question? 4.12, number 4. 4.12, number 4. So anyway, let's read first. Use the limit definition of the derivative to determine the derivative function of the following functions, then determine the equation of the tangent line at the given point. Okay, so number 4 is the function 1 over x minus 2, and x point is negative 1. Okay, so 12, number, just say 4, I hope. Number 4, yes. Okay. So u is 1 over x minus 2, and later on x equals to negative 1 when we get x minus 2, negative 1. Okay, let's do this. Limit definition of the derivative, right? So let me write here, since it's a function of x maybe, and if you want, call it f of x. Say that that's what you're doing. Anyway, the derivative in general is the limit as h goes to 0 of the function at x plus h minus the function at x over h. Then I'm putting in what the function is, so it's 1 over x plus h minus 2 minus 1 over x minus 2 all over h. A little bit annoying, but we have to be able to know where this all came from before we move on. So now I want to put these fractions together over a common denominator, which will be x plus h minus 2 times x minus 2. So I'll have, wobbly line, I'll have x minus 2 minus x plus h minus 2 all over, that line a little longer, right? Not pretty. All over h. Now I can put the h over there, making it a little bit nicer. So my denominator will be h, x plus h minus 2, x minus 2. Numerator now simplifies to x minus x, negative 2 plus 2, and a negative h. Now the h's cancel, which was the whole point that I was hoping for. And so I have negative 1 over x plus h minus 2, x minus 2. Just so I can fit everything in, I'm just going to continue over there. Now, h goes to 0, and in this rational function in h, it has no problem. Plugging in a 0, I get negative 1 over x minus 2 squared. So that is the derivative, which, because I have derivative properties as well at this stage, I can easily verify, yes, that is what it should be. But you have to show enough work to show how the limit definition gets you there. So now, do that. That's my derivative, right? So now, for the line tangent at x equal to negative 1, let's make that line y equals mx plus b. The slope m is exactly the derivative, at this x value in question, which is negative 1 over negative 1 minus 2 squared. So that is negative 1 over negative 3 squared. So negative 1 over 9. Let's update to y equals negative 1 over 9x plus b. Now when x is negative 1, y is the function value at negative 1. Not the derivative, the function value. And the function is 1 over x minus 2, not x, goober. Negative 1 now. Negative 1 minus 2. That negative 1 doesn't even look very good. There we go. So that's negative 1/3. So that means I'm going through the point negative 1, negative 1/3 that I can plug into my straight line equation. Negative 1/3. Fractions are never fun, let's be honest. Plug in the x value plus b. So I have negative 1/3 on the left side. I have positive 1 over 9 on the other side. So that means b is negative 1/3 minus 1 over 9. This guy over here is 3 over 9, or negative at least. So it'll be negative 4 over 9. This looks very familiar. So my equation finally is y equals negative 1 over 9, x minus 4 over 9. There we go. Easy peasy. Well, not really. These are a little long and tedious. I don't know how many of you actually look at these videos, but you know, I'm writing out the solutions anyway. I figured, why not record what I'm doing? Maybe it helps someone. Next, a question. 5.2, number 4. No, don't do that. 5.2, number 4. Let's see what that is. Where is my questions? There it is. 5.2. 5.2, number 4. I want to find the derivative of the given function, stating each property that I'm using at every time. Okay, I'm going to have to drag this over so I can copy this down correctly rather than flipping back and forth. Okay, so I want to find, let's just call this f of x, and it's negative 4x to the 5 plus 3x squared minus 5 over x squared. Now, right away, I can rewrite this to make the last term also a little bit more power rule ready. So then, my derivative is going to be, first of all, the derivative of each term. So in these questions, I need to show every property or understand every property. Even if I combine some of them, like I'm combining the sum and the difference property, right? That's okay. Sum difference property, I have to say what I've used, maybe just one, maybe a couple, whenever I've used it, every line. So now I'm going to leave the negative 4 up front. That's the constant times the function property that I'll just use over and over. So that's just one property, constant times a function property. Let me move up a little bit. Then it's the power rule. No. 4 times 5x to the 4. I don't merge them right away because I don't want to hide what I'm doing. Though you certainly can if you want to. Power. just makes the grading easier if you show all the detail. And that's it. There's nothing more. Oh, okay. I don't care to simplify that. The question didn't say I should. That's my answer. Very nice. Next question. Next question is 5.5, number 10. 5.5, number 10. Let's see what that is. 5.5, number 10 is down here, but let's read the question first. Find the derivative for each of the following functions. Okay, so I don't have to state every step. I just want to copy this function over so I can see what I have to work with. F of x squared plus 1, x squared minus 2 over 3x plus 2. Okay. The derivative is going to be a quotient rule first. I'll just leave usually I do the bottom first, but it doesn't matter. I'm going to write it out just in case there's someone watching that is not quite sure what's happening, right? Derivative of the top times the bottom. It doesn't matter what the top and bottom is or are. Minus the top. How complicated it is doesn't matter right now. I'm setting myself up. Times the derivative of the bottom. And many times people try and do too much in one go. I'm not ready for these top derivatives, perhaps. Bottom squared. If I did this at the same time, I'm going to make a mistake. And I don't want to make a mistake. I'm just going to pause here because I'm paranoid. I just want to see if I'm actually recording. Voice. Everything looks okay. Good. Don't want to do all this and then the video doesn't actually work. That would be disastrous. Then I have to do it again. Okay. So now this derivative here requires a product rule that I will emphasize. You don't have to, but I will because it's a teaching tool as well. Derivative of the first times the second plus the first times the derivative of the second. All of that multiplied with 3x plus 2. And then the second term at the top, squeeze it in. I'm gonna squeeze it in. It's just 3. All over. So yes, with more steps, you have to copy these other things down over and over and over. But at least you're safer and you have the right answer. Isn't that worth it? So it's 2x times x squared minus 2 for this guy, plus that bracket x squared plus 1 times 2x again. All of that times 3x plus 2 minus x squared plus 1. Just copying things down, not doing anything else. I don't copy and simplify. My personal rule to avoid silly mistakes. There we go. I don't care to simplify that. Why? Why would I waste my time? I've done pre-calculus. I know how to simplify. I don't have to prove it at every step. Depending on the next question, we'll see if we can fit it in. Next question. We've done that one, right? Ooh, we're speeding along. 6.1, number 8. Let me just see what it is. See how much space I need for it. 6.1, number 8. 6.1, number. Well, chain rule, yeah. Define an intermediate variable and use a detailed chain rule to determine the following derivatives. Number 8 isn't bad, okay. I think I can fit that in. 6.1, number 8. I can't see number 8 on this screen. Okay, so I have, let's just call it y. I don't care. Doesn't matter. 1/2 x, no, not x. 2x to the 4 plus x all to the -3. Clear chain rule here, right? Let u be the inside function. That almost looks like a 2 there. It's not, there we go. 2x to the 4 plus x. Then y is 1/2 u to the -3. So the chain rule says dy dx is dy du times du dx. Loosely speaking, or casually speaking, the derivative of the outside function times the derivative of the inside function. Derivative of y with respect to u. Now, it's a small function. You can say -3/2 if you want to, u to the -4. It's okay. Or separate them. I don't care. Times the derivative of the inside function, which is 8x cubed plus 1 brackets. Almost done. I just have to put back what u is. I don't change a thing. Put it in. Then the rest. Oh, come on. That's 2. It's a 3. Let's make it super clear what that is. That is a 4. You just put it in, what u is in terms of x. Don't change a thing. Detailed. By using the substitution variable, you show the detail, setting up the chain rule. Nice. Very nice. This is a short one. We're almost done. It's over so fast. What is the next question? 7.11, 6 first. 711, number 6. Let's see what that is. I don't know what that is. Let's find out. 711? Ooh, that's way out there. Determine derivative. Find the derivative for each of the following functions. 11. I see you. No. 6, right? We're at 711. We're doing number 6. Gotcha. Okay. And number 6 is y equal to 2 times 7 to the x minus x squared. Of course, maybe you feel that, ooh, this video is going way too fast. It's a video. Pause it. Go back. Rewatch it. Slow it down. Slow down the speed. So many options. Oh, technology. Wonderful thing. Okay, so they just say do it. All right, do it. Derivative. Constant times a function in front. I'll emphasize it. You never know who's watching. Maybe someone's a little shaky on this. Let's have a teaching moment. Why not? Now, derivative of the general exponential function. It's not base e. It is the exponential function, but because it's not base e, you multiply by the natural log of the base. And then x squared just becomes 2x. Don't do anything else. It's done. It's done. It's done. What was our next question? Number 23. 711. 23, I'm just going to write it down. It is a little log action. Y equals log base 4 of 2x over x plus 1. I'm going to do both ways. Split it right down the middle. First way is to to not alter this function, to take it just the way it is, which is fine. You can do it. How much detail do I want to show here? Well, I'll do it this way. I'm not going to define a u variable. I have my inside function here, right? Brackets aren't shown, but there are brackets. So it's the derivative. Let me do it. Let's make it super clear. Yeah, sure. Let's say u is 2x over x plus 1. Then y is log base 4 of u. So the dy dx is dy du. Always write this if you are not super comfortable. Maybe I wasn't quite comfortable there, right? I want to do this. Make sure you're right. It's okay. It doesn't take long. It took seconds. Derivative of the outside function, well, this is a general base log. I rewrite it to a natural log. Change of base formula. Yeah, good stuff. Then this, maybe let's put a little line here, I can see as a constant times a function, right? So it's 1 over natural log 4 times the derivative of this guy, 1 over u. That's the first part of the chain rule. Then the derivative of the u function, which maybe I don't have space to put there. So I'm going to just remind myself what still needs to be done. I can actually do it sort of two birds here. Replace back what u is. Don't change a thing. It's unpleasant. That's what it is. I put it back. Oops, eraser mode. Eraser mode. There we go. Now I have to focus on the derivative of this guy. Quotient rule. Bottom squared. We'll just do it in one go. Derivative of the top times the bottom minus the top times the derivative of the bottom. You're done. Is that the best way to do it? No, absolutely not. Absolutely not. Always look when it's a log function. Can I make this look better before going to the derivative? Yes, I can. Log of a quotient is the difference of the logs. But remember, you need brackets in the second one for sure. But if it helps you, make you feel better, brackets in the first one too. Because it's log of the bottom. That's a log property. Now I can, if I want to, rewrite this further. Because it's a general base, it's going to be the change of base formula again. Two separate terms. I don't want to factor out a natural log 4 or anything like that. Though, technically, I suppose you could. Now, I don't even have to think about a chain rule. Well, okay, sure, there is a chain rule. I'm sorry, this looks very ugly. I need to put this D nice and tight. Tight. Okay. Constant times a function. Yes, derivative of the outside function times derivative of the inside function. Don't cancel the 2's. Don't do it. Don't do it. Not in the first line. Constant times a function. Derivative of the outside function. The derivative of the inside function is just 1. Now, which one looks nicer? This guy or this guy? I'm pretty sure it's no contest. And there we go. That is the end. That was super fast. Easy peasy. You're done. You are done. Until next time.